What is up, winning team? Hello, welcome and welcome back. We are in chapter 10 of Beyond the Veil, the bubble theory and the fourth dimension, a beginner's journey into higher dimensions in modern physics, written by Jamil Chamberlain, our current book of choice. We're about to go into chapter 10, shedding light on dark matter and energy. Now, if this is the first of all these videos you're hearing, we are delving into the fourth dimension. Well, and interestingly, dark matter and dark energy, as you would have known if you've been here throughout, right? 95% of our universe is dark matter and energy. So we're going to delve more into that. If this is the first of the videos you're watching, there is a whole playlist in the description box with all of the videos, including an introduction video to explain exactly why we're doing all of this. Also, you can purchase the book yourself on Amazon. The link is in the description box. And if you yourself are already a scientist and you're curious for more details on the theory and to get into more of the nitty gritties, there is also a link to where he has done even more in-depth, more detailed information around all of these ideas. Obviously, this book is written as a beginner's journey. So if you're already, you don't class yourself as a beginner, you want to go a bit deeper with it all, feel free to check that out. It may or may not answer some of your questions. You're also free to ask them in the comments, and I will ask the author myself, of whom I have also been asking questions. So let's get straight into this. Introduction. Imagine standing on a trampoline with a massive bowling ball placed at its center. The fabric of the trampoline wraps under the weight, creating a dip that influences how smaller balls roll around it. This simple analogy captures the essence of gravity in our three-dimensional world. So let's read that again. Imagine standing on a trampoline with a massive bowling ball at its center. The fabric of the trampoline warps around under the weight, creating a dip that influences how smaller balls roll around it. This simple analogy captures the essence of gravity in our three-dimensional world. But what if gravity isn't just a force emanating from mass, but a ripple in a higher dimensional fabric? The bubble theory invites us to rethink gravity and fundamental forces of nature by introducing interactions within the fourth spatial dimension. This chapter explores how gravity could emerge from these higher dimensional interactions and how this perspective might unify the fundamental forces, right? So if you want to know about the fundamental forces, we discussed those earlier on in the book. He kind of broke it down. We're looking at the parts of the atoms and how the atoms break down into the smallest, which I believe it's electrons, quarks, and something else are the elemental particles. And then you had the fundamental forces, which were gravity. Hold on, let me go back. Electromagnetism, strong nuclear force, weak nuclear force, right? So go back in the videos if you guys want to hear about that. So, gravity as an emergent phenomenon. Traditional understanding of gravity. In classical physics, gravity is described by Isaac Newton as a force of attraction between masses. Later, Albert Einstein revolutionized our understanding with his general theory of relativity, portraying gravity not as a force, but as a curvature of space-time caused by mass and energy. Despite these advancements, gravity remains elusive when it comes to unifying with other fundamental forces, electromagnetism, the weak nuclear force, and the strong nuclear force. So those are the ones I just mentioned. Okay, it remains elusive. The bubble theory's perspective. Oh. Sorry. I can't believe it was 63 pages in. I just remembered something that he said. The bubble theory's perspective, the bubble theory proposes that gravity is not a fundamental force, but an emergent phenomenon resulting from interactions between multiple bubbles in the fourth spatial dimension. So hear that. The bubble theory's perspective proposes that gravity is not a fundamental force, but an emergent phenomenon resulting from interactions between multiple bubbles. So, coming from the fourth dimension, in the fourth dimensional space, just as ripples on a pond emerge from the movement of objects within the water. Gravitational effects in our universe Okay, let me say this again. Just as ripples on a pond emerge from the movement of objects within the water, gravitational effects in our universe arise from the dynamics of bubbles interacting in higher dimensions. This perspective suggests that we may perceive what we may perceive as gravity is a manifestation of these interdimensional interactions. This is just, hold on. I'm absolutely loving this because you know what, guys? I've never really felt like gravity was explaining enough, particularly because, I don't know, it just, anyway, I don't have the words to explain, so we'll just keep reading. But I was never really like, it just didn't quite, it was like, I felt like, okay, this is the best way I can explain it. I felt like it's like how me as a teacher, right? I teach mainly maths, chemistry, and physics, right? Up to age 18 in this country. So to me, there's a lot of things you get taught in school that are kind of like highly oversimplified things that if you really go deeper, it goes a lot deeper than what you're being told. And so when it's similar for me with a lot of these fundamentals where like gravity felt like a oversimplification to kind of get you across the way, but like didn't really explain enough. I guess that's the best way I could describe it. So anyway, unifying fundamental forces through the S energy field. One of the most tantalizing prospects of the bubble theory is its potential to unify all fundamental forces. Oh, that's interesting. So now we're getting into, because I was thinking, and I didn't mean to ask him and I forgot. I got distracted by talking about other things. But why he chose the bubble theory of all, because obviously we look at different theories and different laws because they explain or don't explain different things. So for example, like I said to you guys about the law of entropy. The law of entropy is so important in science. It's the reason why I found the whole of my first batch of God versus Science videos were based on the law of entropy. Because entropy is one of the few proofs of the existence of time itself. Hence the fact that we all observe time. It's something we all can observably see. Like there was time 0 before you watching this video, then there was time whatever, you could time every minute whatever, but the point is at some point you started watching this video, the time was 0, and now you're watching it, the time is like 7:13 or whatever. And the fact there's those two distances is proof of the existence of time, and entropy is also the proof of the existence of time, for the sake that I'm now older, I'm closer to dying than I was 7 minutes ago, right? Just by default, even if how long I'm going to live, right? I'm always going to get closer to death. And that's, again, a proof of entropy. So I like when things tie things together because it kind of strengthens an argument. If we're saying that one of the most tantalizing prospects of the bubble theory is its potential to unify all fundamental forces, that helps because the fundamental forces weren't necessarily unified previously. The S energy field, which governs the interactions of bubbles, serves as a common thread linking gravity with electromagnetism, the weak force and the strong force. By existing within the fourth dimension, bubbles can influence each other in ways that transcend our three-dimensional understanding, allowing for a cohesive framework where all forces emerge from higher dimensional dynamics. I'm so sorry about my reading. The problem that's happening is I'm trying to read while my brain is going 100 miles thinking about what's being said. So there's like a bit of a glitch situation happening where I'm just trying to read what I'm looking at, but my brain is already like moving 100 miles ahead. Bridging quantum mechanics, as you guys know, probably my favorite of all the areas of science is quantum mechanics, and which is also part of my own research, and general relativity, the challenge of unification. Quantum mechanics excels in explaining the behavior of particles at the smallest scales, while general relativity provides a robust description of gravity and the large-scale structure of the universe. However, integrating these two pillars of modern physics has proven to be a formidable challenge. The discrepancies between the probabilistic nature of quantum mechanics and the deterministic framework of general relativity have left physicists searching for a unified theory. So let me just think about this. The discrepancies, the probabilistic nature of quantum mechanics and the deterministic framework of general relativity have left physicists searching for a unified theory. Bubble theory's approach. The bubble theory offers a novel approach to this unification by positing that both quantum mechanics and gravity emerge from the same higher dimensional interactions governed by the S energy field. In this framework, quantum phenomena like superposition and entanglement are manifestations of bubble interactions in the fourth dimension, seamlessly bridging the gap between the quantum and the gravitational. So in other words, it's kind of like essentially the reason why certain things are not adding up the way that we would logically think they would add up based on what we do know is because we've been looking at it from a three-dimensional standpoint, and actually the answers do not lie in our three-dimensional laws, but in actuality in what's taking place on a fourth spatial dimensional level. So here, visualizing the bridge. Consider the analogy of a hologram where a three-dimensional image is projected from a two-dimensional surface, right? Similarly, our three-dimensional universe could be a projection of interactions occurring in the fourth dimension. This okay. That actually makes so much sense. This higher dimensional activity could give rise to both the familiar forces and the mysterious quantum behaviors, providing a unified tapestry of reality. Potential evidence and observational signatures. I like this a lot. Okay, gravitational wave patterns. The bubble theory predicts that gravitational waves, ripples in space-time, detected by observations like LIGO, I don't know what that is, LIGO, could carry signatures of higher dimensional interactions. These waves might exhibit unique patterns or anomalies that deviate from predictions made solely by general relativity, hinting at the influence of interdimensional dynamics. We've got black hole behavior. So black hole was one of those things that we talked about, why there's a need to look into other dimensions, because obviously these are the types of things that we currently are not as able to assess. Black holes with their intense gravitational pull serve as natural laboratories for testing theories of gravity. The bubble theory suggests that the merger of black holes could involve interactions between bubbles in the fourth dimension, potentially leading to observable deviations in the gravitational waves they emit compared to standard model predictions. So I guess, and I don't know if this is what he's saying, but this is what I'm understanding, it's almost as if a black hole in and of itself could be some kind of like an overlapping between bubbles, as in between universes, and hence, or just the points of fluctuation, or all these different things that have come up. Hence the extreme, what we call gravity, the increase of the gravitational pull that exists. That's quite interesting, because the truth is, and if you think about the black holes, if you think about it for a second, the truth is that we don't really know what happens on the other side of the black hole. It's kind of like, so because we don't really know, to us being sucked into a black hole is like being almost sucked into nothingness. But that's just because from our standpoint, from the third dimension, that's what we can see in our universe with our S signature according to our bubble, according to the bubble theory. Hence, for all we know, you could get sucked into the black hole, or something could get sucked in there, find itself in another universe, and just be, God knows what could be happening. The possibilities are endless. That's if I'm understanding properly. Like I said, guys, I'm just giving my thoughts here. So we've got cosmic scale structures. Large scale cosmic structures such as galaxy clusters and voids could be influenced by the collective behavior of multiple bubbles. Analyzing the distribution and movement of these structures might reveal patterns consistent with a higher dimensional interactions, providing indirect evidence for the bubble theory. That's really interesting. This is getting so juicy. Like, I almost feel like splitting this up into two videos, because we're going into mathematical framework, and we've got higher dimensional field equations, energy conservation dimensions, quantum mechanics integration. I feel like this should be a separate video. So I'm going to leave this video as this, and leave on the thought of, what if gravity is a manifestation of interdimensional interactions? What if? And so we've kind of set the tone for how that could be, and how that could be that gravity could be a lot more to do with what's happening in the fourth dimension. I think we'll do separately. So we'll do a second part of chapter 10, looking at these examples, because I don't want to rush through them and I don't want these videos to be too long. So come back for the next video. We're going to talk about the mathematical framework simplified, challenges, and future research of this concept in the next part. So if you guys are enjoying this, I'll see you guys in the next part of this. This is getting so juicy, so interesting. Yeah, so I'll see you guys in part 10, I guess, chapter 10b, if you will. Other than that, if life's a game, it's pay to win. If you, like I said, if you want to watch the rest of this, it's all going to be linked in a playlist in the description box down below. So go and click that link. Go and check out the rest of the videos. There's an intro in there. The book is also linked for you to purchase off of Amazon. Highly recommend, super cheap, and it's nice to be able to annotate my own versions while I'm like thinking things. And like I said, if you're a scientist, you already know more about this kind of thing and you want more of the sciencey science stuff, feel free. There's a third link in the description box with more information is put in more detail for those of you who are more comfortable with this kinds of science, to get more kind of the explanation, a deeper, more detailed explanation about a lot of these concepts. But we'll come back to this in the next video. So if life's a game, it's pay to win, you guys. God bless you all. God loves you. I love you. And I'll see you in my next one.